Here we go. For math today, we are on lesson 3.8 in our student activity book. And we're going to start off just kind of looking, we did a little bit of this in 3.7, but we're kind of looking at the comparisons and the differences in the answers that we get when we, first off, just compare two fractions versus adding them, subtracting them, and multiplying them. Those are the four skills that we've learned so far with fractions. And it's really, really important that you remember how to do each one of them and the differences within them. So just the main part is remembering that when we're adding and subtracting, we have to have that common denominator, okay? We cannot add and subtract without a common denominator. Well, we could, but we'll get the wrong answer. And that should never be the goal of our work. We should always want to have the right answer. But when you multiply, you don't have to have a common denominator. When you multiply, you just go for it, okay? Multiply numerators, multiply denominators. But that adding and subtracting has to have a common denominator. So let's look at these first two fractions they've given us, 2/5 and 7/10. Now, hopefully you remember that butterfly method for comparing them, for doing our greater than, less than, or equal, because that's going to make it a lot easier. So I could do my 5 times 7 is what?
35.
35. And 10 times 2 is?
20.
20. So which fraction's bigger?
7/10.
7/10. So 2/5 is less than 7/10. If you'll notice though, in the box up here, they went ahead and found their common denominators there in order to compare them. And if you do it in that step, it just means you don't have to do it in the next one when you get to adding. So either way works. Let's come back to our 2/5 and 7/10. If I'm adding these two together, 2/5 plus 7/10, I can't add them yet, right? Because they have different denominators. So I have to find my common denominator. And remember, the way that we start that is we start off by thinking, okay, can 5 go into 10? Yes, it can. So I need to make this 2/5 something over 10. Well, how do I get from 5 to 10?
Times 2.
Times 2.
Times 2.
So then I have to multiply my numerator times 2. What's 2 times 2?
4.
Okay, awesome. So 2/5 and 4/10 are the same thing, right? Yes. So now I have 4/10 plus, do I need to change my 7/10?
No.
Nope, that can stay the same. 4/10 plus 7/10. Add my numerators. 7 plus 4 is 11. Do I add my denominators?
No.
No, my denominator stays the same. It's a 10, it's a 10. I'm going to write down a 10. But 11/10, that's kind of a yucky looking answer, isn't it? We got to fix that answer. How am I going to change that 11/10 to a mixed number?
1 and 1/10. 1 and 1/10.
Well, I hear you telling me the answer, but I asked, how am I going to do that?
Subtract 11 by 10, and there's the 1 in the tenths, so you have to put a 1 for the whole number, and then there's and 11 is 1 more than 10, so you put in 1 and 1/10.
Okay, good. I see how you're getting to the subtract, but I'm going to say divide just so we don't confuse people. It is 1 and 1/10, but remember, we see how many times the bottom can go into the top. How many times can 10 go into 11? It goes
1
time. And then here's your subtraction part, right? Here's that subtraction you were saying with the 1 left over. So 1 and 1/10. Okay, awesome. That's when we filled out our adding box. How about subtracting? Can I set this up the same way I did the other one? 2/5 minus 7/10. Can I set it that way? No, why not, Landon?
Because you always, when you're subtracting, you always have to have the greater number on the top, and 7/10 is greater than 2/5.
Yes, 7/10 is greater than 2/5, so 7/10 needs to come first. And this is where I'm going to put that little asterisk, that little like footnote, you know, like when we have our reading where sometimes there's a little asterisk or a footnote that's giving you additional information. I know that we say that you always have to put the larger number first. That's in 5th grade math and below. When you start to get older, you'll get into negative numbers, and it won't always be that way. But for now, yes, because I don't want you to get to like 6th, 7th, 8th grade and be like, well, Miss Triplett in 5th grade said that you always put the bigger number first, okay? Because you don't, but in 5th grade math, you do. So I just want to clarify that. So here we go. So I'm going to put my 7/10 first, right? 7/10 minus 2/5. Can I solve it the way it is?
No.
No, because I've got different denominators, but my 7/10 is going to stay the same. And I already know that my 2/5 is going to be what?
4/10.
4/10, because it's the same as it was up here. 7/10 minus 4/10 is what?
3/10.
3/10. 7 minus 4 is 3. Denominator stays the same. 3/10 is my final answer. Awesome. And multiplying. Who would have ever thought that multiplying would be the easiest one over adding and subtracting, right? Who would have thunk it? 7/10 times 2/5. Do I need to do anything in order to solve this problem?
No.
Nope, I can just go for it, okay? If you want to cross cancel, you could. You could look at your 2 and your 10 and notice that you could cross cancel those, but you don't have to. 7 times 2 is 14. 10 times 5 is 50. I'll take that answer. When you get older, though, they'll make you simplify it. If you wanted to cross cancel, your 2 divided by 2 is 1. 10 divided by 2 is 5. So that would have been 7/25. Are 14/50 and 7/25 equivalent to each other?
Yes.
Yeah, because I just multiplied both the top and the bottom by 2 to get to 14/50, right? As long as I'm multiplying or dividing the top and the bottom by the same number, they're equivalent. Awesome. Great job on that fraction box. Let's look at the next fraction box. And you guys are going to have a fraction box on your homework. So make sure you're understanding or asking questions if you're not. Here we go. 3/5 and 4/7. Let's compare them. We're going to do the diagonal to compare. 5 times 4 is?
20.
20.
7 times 3 is?
21.
21. So 3/5 is greater than, less than, or equal?
Greater
Greater than 4/7. Good, because 21 is greater than 20. So I could compare it just like that. Now we got to add them, and this is going to be tough because they don't have common denominators, right? Well, not super tough. You guys can handle it. 3/5 plus 4/7. All right, can 5 go into 7 equally?
No.
No, let's count by 7s. How about 14? Can 5 go into 14?
No.
No. 21?
No.
No. 28?
No.
No. 35?
Yes.
Yes, there it is. So I need to set up 2 new fractions with 35 as my denominators. Okay. And now, how do I get from 5 to 35?
Times 7.
Times 7.
Times
So if I
7.
multiply that by 7, I have to do my 3
21.
times 7. 3 times 7 is
21.
21. Awesome.
And
And now, how do I get from 7 to 35?
Multiply by 5.
Times 5. I love it. Yes. What's 4 times 5?
20.
20. 21 over 35 plus 20 over 35. What's that going to equal?
41 35.
35.
You guys got it. I love it. 41 35. Can I end my answer that way?
No.
1 and 6 35.
Ooh, I love it. Let's see. I'm going to turn my book a little bit here to give myself some room. 41 divided by 35. It goes in there 1 time. Subtract, I have 6 left over. So just like I heard somebody say, 1 and 6 over 35 is my final answer. Did we do okay on adding?
Yep. Yeah.
All right, let's take a look at subtracting. So which fraction am I gonna have to put first?
3/5.
3/5, you got it, because that's the greater fraction. 3/5 minus 4/7 is the same as 21/35, right? I already did my equivalent fractions up here. 21/35 minus 20/35. Well, what's 21 minus 20?
1.
1.
1.
35th.
1/35. Keep my 35 as my denominator. Okay. And now for the very last step in the fraction box. Let's multiply. 3/5 times 4/7. I can't do any cross canceling on this one, can I?
No.
Nope, nobody shares any factors. So let's just go for it. What's 3 times 4?
12.
12. What's 5 times 7?
35.
35. Sweet. All right. Questions on these two fraction boxes? All right, Jackson, will you read us what's going on with our dear friend Puzzled Penguin today?
Dear math students, one of my friends said that he would give me half of his sandwich to me and half of his sandwich to my sister. My sister said, but then you won't have any left for yourself. That doesn't make sense to me. I know that 1/2 plus 1/2 equals 2/4. My friend should have plenty left for himself. Did I do something wrong? What do you think?
All right, in the chat, what did Puzzled Penguin do wrong? Send it to me in the chat. You don't need to write anything down, just really brief, couple words. What did he do wrong? He's supposed to add, so just saying he added isn't the complete answer. And tell me, what did he do that added wrong? What part of his adding was wrong? Oh, I love it. And I love the math words you guys are using too. Yes, I see a lot of he added the denominators, right? He said 1/2 plus 1/2 is 2/4. We know that we add the numerators. We add the 1 and the 1, which gives us 2. But do we ever add our denominators?
No.
No. We never add or subtract our denominators. So we should end up with 2/2, which is the same as
1.
1 whole, which is this whole sandwich, right? It's the same as 1 whole, which is this whole sandwich. So then his friend has nothing for lunch. All right, you don't need to write anything. I just like to talk about Puzzled Penguins. Let's turn the page and take a look at some word problems. Yay. Miguel, do you want to read the first one to us?
Okay. Yesterday, Mr. Swenson made 2 3/4 quarts of strawberry jam and 1 1/8 quarts of raspberry jam. How much more strawberry jam did he make than raspberry?
Awesome. Let me give you guys one little hint that I have, because this comes in handy when you're taking tests a lot of times. They throw in some funky names sometimes when you're taking tests. Here's the thing. Does the name, often the name does not change the question or the answer or the reading or any of that. So I could just say Mr. S made 2 3/4 quarts of jam. I could say Mr. Bob, as long as every time I see Swenson, I'm replacing it with Bob, right? So, and this is not pointing out anything to you, Miguel. This is just general for the class. If you get stuck on a name, just change the name. Change the name to something that's easy for you to say. Use your own name. You can always use my name. Just kidding. All right, so yesterday he made 2 3/4 quarts of strawberry jam and 1 1/8 of raspberry jam. how much more strawberry jam did he make than raspberry? Are we adding, subtracting, or multiplying, friends?
Subtracting.
Subtract.
Subtracting, yes. We have, oh, and it doesn't say we have to write equations. Lucky us. 2 3/4 minus 1 1/8. Let's find our common denominator. What's our common denominator going to be?
8.
8, yes, because 4 can go into 8. 4 times 2 is 8. 3 times 2 is 6. Can I do 6 minus 1?
Yes.
Yes, that means I don't have to borrow. What is 6 minus 1?
5.
5 over 8, right? Denominator stays the same. 2 minus 1 is?
1.
1.
One.
So what's my answer?
1 and 5/8. 1 and 5/8.
1 and 5/8 monkeys?
More strawberry jam.
More strawberry jam.
1 and 5/8 quarts.
Yeah, okay.
1 and 5/8 quarts, right? Because we're talking about quarts of jam. All right, how about the next one? Mr. Swenson is making 2/5 quart of grape jelly.
Again?
He will give half of this amount to his neighbor. How much jelly will the neighbor get? Add, subtract, or multiply?
Multiply.
Multiply, because he's getting half of the 2/5. Whew, you guys could probably beat me in doing this one. 1/2 times 2/5. Oh, I could even cross cancel, can't I? Because I've got my 2's. Well, let's see. If I don't cross cancel, I get 2/10. If I do cross cancel, because remember the same number across from each other, I can just cross it out. And I get 1/5. So I have 1/5 quarts. That's how much his neighbor's getting. 1/5 quarts of jam.
Yay.
Yay. Jaslyn, do you want to read number 6?
Sure. Mr. Swenson is also making 2 1/6 quarts of cherry jelly and 3 1/12 quarts of orange jelly. He will mix the two kinds together. How much of this mixed jelly will he have?
All right. Add, subtract, or multiply?
Add.
Adding, yep, because we're trying to figure out how much he's going to have all together, right, when he mixes them together. This Mr. Swenson is really into making jelly. All right. 2 1/6 plus 3 1/12. What's my common denominator going to be?
12.
12. I know that because 6 can go into 12 evenly, right? My smaller denominator goes into my larger denominator. How do I get from 6 to 12?
Times 2.
What's 1 times 2? What's 1 times 2?
2.
2.
Yep. 2 plus 1?
3.
3. Keep my same denominator. 2 plus 3?
5.
5. What's my answer?
5 and 3
5 and
12.
3 12.
5 and 3 12.
5 and 3/12 chunks of cheese?
Quarts.
Quart.
Quarts of
Quarts.
Okay, don't forget your labels. Do any of my friends from Mr. Baker's class want to read number 7? Anybody want to unmute and just go for it?
Yesterday, Mr. Swenson made 7/10 quarts of blueberry jam. His family ate 1/10 of it. How much of the blueberry jam is left?
In the chat, am I adding, subtracting, or multiplying? In the chat.
Well, let's.
Looking good, looking good. So when we say how much is left, that's our key that we're subtracting. Okay, how much is left? That's our key that we're subtracting. So which fraction is larger, right? Because in 5th grade, we always put the larger fraction on top. Which fraction is larger?
7/10.
7/10. Yep. Super cool that they gave us common denominators already. 7/10 minus 1/10 is?
6/10.
6/10 what?
Quart.
Wait, huh?
6/10 quarts. Yep, 6/10 quarts. That's what's left. All right. Oh, this next one's a little bit longer of a problem. Do I have a volunteer who wants to read?
Can I read?
Go for it.
Suppose Mr. Swenson has jars that hold 5/6 quart, jars that hold 3/4 quart, and jars that hold 2/3 quart. Which size holds the most? Which size holds the least? How do you know?
So we need to put these in order from least to greatest. So to do that, we need to find a common denominator that works for 6, 4, and 3. Because we're going to need to come up with common denominators for all of these. So let's see.
Oh gosh.
Let's start with my 3 and my 6. Can 3 go into 6?
Yes.
Yeah. Can
Yes.
4 go into 6?
No.
No, it can't be 6, right? Let's count by 6s, and what comes next?
12.
Well,
12. Can 3
Oh.
go into 12?
yes.
Oh.
Yes.
4
Yeah.
go into 12?
Yes.
Yeah.
Awesome. There's my common denominator. So I need to make 3 new fractions with 12 as the denominator. How am I going to get from 6 to 12?
Times 2.
Times
6 times 2. What's 5 times 2?
10.
10.
You got it. How am I going to get from 4 to 12?
Times 3.
Times 3. What's 3 times 3?
9.
9.
Nine.
Yep. How do I get from 3 to 12?
4.
4 times
4. What's 2 times 4?
8.
8.
Look at that. They were already in order, weren't they? 10, 9, 8. They were already in order from least to greatest. Which size holds the most?
5/6.
5, 6.
5, 6.
6.
5, 6 quart, I'm going to abbreviate to QT, holds the most. Which size holds the least?
2/3.
No, what was it?
2/3 quart holds the least. How do I know?
Because we made them into common denominators so you could tell.
Yeah, we made equivalent fractions with common denominators. Equivalent fractions with common denominators. I'm going to abbreviate denominators. Awesome sauce. All right, we got one left. Somebody go ahead and just start reading number 9 who hasn't read yet.
Mr. Swenson made 6 and 2/3 quarts of jam last week. This week, he plans to make 1 1.5 times this much. How much jam will he make this weekend?
In the chat, add, subtract, or multiply. I'm getting a variety of answers. Can I underline a clue word here for you?
Yes.
What's that clue word tell me I'm going to do?
Multiply.
Multiply, yep. 1.5 times this much. 1.5 times 6 2/3. Okay, here's the tricky part. 6 2/3 times 1 1/2. Do I do 6 times 1 and then 2/3 times 1/2?
No.
No. Ooh, I loved how dramatic that was. What do I need to do?
You have to make them in fractions greater than 1.
Yes, you got it. You should teach my class, I think. 3 times 6 is 18 plus 2 is
20.
20 over 3, right? Because I keep my same denominator. How about 1 1/2? What's that gonna make?
2,
3 and
3.
3.
4 halves.
Oh my
3
goodness.
halves.
2 times 1 is
2.
2
3.
plus 1 more,
It's 3.
3. 3 halves. Okay. So again, this one we can do some cross canceling or not. Okay. If I don't, I end up with 20 times 3, which is 60, over 6. Oh, I can simplify that pretty easy, right? How many times does 6 go into 60?
10.
10 times.
10 times.
10.
10 quarts would be my answer. If I decided to simplify before, look, I've got 3's on the corners. I can just cross those both out. I also have 2 and 20. Does 2 go into 20?
Yes.
Yeah. So 2 goes into 2 one time. It goes into 20 10 times. So I would have ended up with just my 10 over 1 from the beginning if I chose to cancel. All right. So I really encourage you guys, like I was doing, to underline those words that are the key words that are helping us figure out if we are adding or subtracting when we do these. In fact, go ahead and take out your homework and let's look through the word problems real quick. We're not going to solve them, but let's go ahead and decide if we are adding or subtracting or multiplying. So I am in our homework and remembering book now for lesson 3-8 on page 61. Homework and remembering book, page 61. Okay. You see you've got 2 fraction boxes at the top to do. We're going to skip those for right now, and we're just going to read through these word problems so we can put down what operation we're going to do to solve them. So the Eagle Trucking Company must deliver 7/8 ton of cement blocks and 5/8 ton of bricks to one place. How
Add.
much will this load weigh? Am I going to add, subtract, multiply, or divide?
Add.
Add.
Because we're figuring out how much will the load. Will all of it weigh together? So I'm going to add on this one. A truck carried 3 1/3 tons of sand, but lost 1/4 ton along the way. How many tons of sand were delivered?
Subtraction.
Subtraction.
It lost some sand, so we're going to subtract because that fell out. We don't have it anymore. The trucking company also needs to deliver 1 2/3 tons of oak logs and 1 7/12 tons of maple logs. Which load weighs more?
Subtracting.
So I guess I should have included one other thing because this isn't add, subtract, or multiply. What do you think we're going to do on this one?
Divide.
Division.
No.
Comparing.
We're going to compare them, right? Because we want to know which of those 2 is bigger. So we're going to compare. We're going to figure out that greater than, less than, or equal. How about number 6? In a load of 3/4 ton steel rods, 1/8 of them are bent. How many tons of steel rods are bent?
Subtraction.
Subtraction. Oh.
Multiply.
Multiply 1/8 of them. The them is the 3/4. So 1/8 of 3/4. That's a multiply. The company delivered 1 3/5 tons of bricks to one building site. They delivered 2.5 times this much to a second site. What was the weight of the load the company delivered to the second site?
Addition.
Supply because.
Apply because it says times.
Times 2.5 times this much. We are multiplying on that one. Okay. All right, everybody take out your planners. Do not leave. Nobody is leaving me. You need to